everyone, welcome to Statistics Show. I am your student teacher Nicole, and for this video, we are going to apply our knowledge on hypothesis testing on population mean to determine if there is a difference between the national average height of adult males and females and the local average height of adult males and females here in our barangay. So sit back, relax, and learn. To start, let us all watch the news report first. The national survey done by the Food and Nutrition Research Institute of the Department of Science and Technology on April 2014 to adult Filipino males aged 20 years old and up claimed that the average height of adult Filipino males is equal to 163 centimeters with a standard deviation of 6 centimeters, and the average height of adult Filipino females is 151.4 centimeters with a standard deviation of 5 centimeters. This is Nix reporting live to ABC News Station, Philippines. Alright, so we will use the claim from this report for our hypothesis testing today. Now let's proceed to the situation and the task. In a national survey by Food and Nutrition Research Institute of the Department of Science and Technology on April 2014 to adult Filipinos 20 years old and older, the average height of males is 163 centimeters with a standard deviation of 6 centimeters, and the average height of females is 151.4 centimeters with a standard deviation of 5 centimeters. You are a local statistician and you are interested to know if the average height of adult males or females in your locality or barangay is different to the national average height. Use the knowledge and hypothesis testing on population mean and do the following. Letter A. Conduct a survey in your locality to at least 30 adults wherein 15 are males and 15 are females. Letter B. Ask for their individual height in centimeters. Letter C. Determine the sample mean height. Letter D. At 95% confidence, test the null hypothesis that there is no significant difference between the national average height and the local average height. Letter E. State your conclusion. To do this, I decided to follow the following steps. Step 1. Conduct a height survey. Step 2. Determine the sample mean height. Step 3. Write the given. Step 4. State the null on the alternative hypothesis. Step 5. Identify statistical tests to be used. Step 6. Perform the computation. Step 7. Decide. And lastly, state the conclusion. Now let's proceed to step 1. Conduct a height survey. I will be using Google Form, text messaging, and direct messaging through Messenger with the help of my friends to conduct a survey. Also, I will ask my neighbors here face-to-face about their heights. I decided to survey 30 females and 30 males since the standard deviation is known and we want to use zeta statistic later for a better computation. Alright, after waiting patiently for their responses, we now have these results. For the females, we have 164 in centimeters, 150, 155, 153, 140, 145, 149, 151.2, 155, 176.7, 168.8, 169.2, 149.8, 156.3, 174.5, 160.0, 139.8, 178.9, 167.3, 169.8, 179.2, 168.5, 152.4, 125, 163, 164.6, 148, 162.2, 154.2, and 160.1, which has a total of 4,751.5. For the males, we have 155 in centimeters, 165, 161.1, 175, 172.8, 169.3, 177.2, 158.4, 166.6, 175.2, 165.8, 171.6, 169.8, 178, 168, 173.5, 179.9, 171.1, 174.4, 161.5, 172.3, 177.8, 176.5, 158.7, 159.2, 160.7, 171.8, 174.8, 185.9, 179.8, which has a total of 5,106.7. Now let's proceed to step 2, determine the sample mean height. To calculate the sample mean height, we just need to add up all the samples and then divide it by the sample size or by the number of samples. Since we already computed the sum a while ago, let's just proceed to division. So we have here for female 4,751.5 divided by 30, we have 158.383 centimeters. For male, we have 5,106.7 divided by 30 equals 170.223 centimeters. So these are our sample mean height. Step 3. Write the given. For females, the sample mean equals 158.383. The sample size is 30. The standard deviation is 5 and the population mean is 151.4. For males, the sample mean is 170.223. The population mean is 163. The standard deviation is equal to 6 and the sample size is 30. Step 4. State the null and the alternative hypothesis. Since the population mean for female is equal to 151.4, our null and alternative hypothesis is written as this in symbols. And since the population mean for males is 163, our null and alternative hypothesis is written as this in symbols. Just always remember that the null hypothesis is the initial claim, and it shows no significant difference, no changes, nothing happened, no relationship between two parameters, whereas the alternative hypothesis contradicts the null hypothesis. It shows that there is a significant difference, an effect, change, relationship between a parameter and specific value. Step 5. Identify statistical tests to be used. Since the standard deviation is known and our sample size is 30, we will use z-test. And since our alternative hypothesis contains an inequality symbol, we will use two-tailed test. Also, it was stated that we are going to use 95% confidence to test our hypothesis. Therefore, our critical values are positive and negative 1.96. And the rejection region is the area on the graph where the set of all values less than negative 1.96 and set of all values greater than 1.96 lies. To obtain this, we just subtract 100 minus 95 equals 5, and then expressing it in decimal form, we have the alpha level 0.05. And then upon looking at the given table after this, we can have this rejection region. By the way, you can find the critical values using the z-table, but if you're using t-test, you should use the t-table. So here is the table, and the one marked with red line is the rejection region. Meaning, if our computed z-value later falls into the rejection region, or if it is less than negative 1.96 or greater than positive 1.96, we will reject our null hypothesis in favor of the alternative hypothesis. It is because the rejection region is the set of all values of the test statistic that cause us to reject the null hypothesis. Step 6. Perform the computation. To do this, we will just substitute our given to the z-value formula. So the formula is z equals sample mean minus population mean divided by the population standard deviation over the square root of sample size. So first, we will solve for the z-value of females. Substituting our given to the formula, we have 158.383 minus 151.4 divided by 5 over square root of 30. Simplifying this, we have 6.983 divided by 5 over 5.477. We have 6.983 over or divided by 0.9129. Computing this, we obtain the z-value 7.649 or 7.65. Now, let's solve for the z-value of males. Substituting our given to the formula, we have 170.223 minus 163 divided by 6 over square root of 30. Simplifying this, we have 7.223 divided by 6 over 5.4772. We have 7.223 divided by 1.09545. Computing this, we obtain the z-value 6.594. Now, graphing the z-value for female, we have this. As you can see, the z-value is located in the rejection region. It is because 7.65 is greater than 1.96. Graphing the computed z-value for males, we have this. Also, as you can see, the computed z-value is located along the rejection region. It is because 6.594 is greater than 1.96. Alright, let's proceed to step 7, which is to decide. Both of the absolute value of our computed z-value are greater than the absolute value of the critical z-value at 0.05 significance level, or both of our z-value lies at the rejection region. Thus, we decide to reject our null hypothesis. Okay, so we are now here at the final step, which is to state the conclusion. Based from our computations, we can conclude that there is a sufficient evidence that the local average height of females and males are significantly different from the national average height. Thank you so much for joining me today. I hope you have learned something from this show. If you have topic suggestions, don't forget to comment down below in the comment section. And if you have some concerns, don't hesitate to send me a message on my social media accounts. Again, this is The Statistics Show. Have a nice day and see you again next time.